Okay, in reference to yesterday, when talking about electrons make what's called a shell game, and that's essentially true. One of the aspects that you will do with that is constructing what we call dot diagrams as well. And what you're doing is essentially taking the Bohr model and showing how bonding actually takes place within different types of elements and molecules. And according to the forensic chemists that at this laboratory, they're taking this sample and put it in what's called a chromatograph. And what that does is it gives a breakdown of the different types of elements that are found inside that substance. Okay, so we will continue with that in just a couple of moments, but notice we've taken a slow progression on what a Bohr model is, the configuration, and what's the difference between the two, the Bohr model and the configuration. Yeah, it's just a linear configuration or linear representation of where those electrons are. But notice we've started with smaller elements. I think the first one we did was nitrogen, and then we kept getting a little bigger, a little bigger. And what I want you to do now is pick a number between 49 and 53. Okay? So what are we talking about when you say 52? What's the element? Maybe tellurium? Okay? So, if we were to do the Bohr model for tellurium, okay? Remember, the atomic number gives you the number of protons, identifies the element, and tells you which one you're dealing with. Okay? Now, again, what does this periodic table tell you? What predictions can you comfortably make when it comes to that of tellurium? True, we've got that, but as far as the, if you want to call it the shell game or the energy levels these electrons are found in, why, you're correct. Why would you say the fifth energy level? Because it's in the fifth period, okay? Now, how many valence electrons do you think tellurium has? No. How many valence electrons do you think tellurium has? It's nothing that thinking about it, looking at this is the only way you're going to be able to tell that. You're correct. How did you come up with 6? Because it's in the 6th column. Okay? Now, one of the things when we're talking about what columns these are in, remember the S and the P can be placed together. What column is tellurium in the P block only? It's in the 4th. Okay? So if we're saying it's in the 4th column of the P block, which is true, why are we so concerned about 6 when we're saying it's in the 4th column of the P block? Because you don't want to skip which block. You don't want to skip the S block. That's part of that energy level too. Okay. With this last couple minutes that we've just talked about, left outside, are we on the bus? Left middle, middle, right middle, right outside. Okay, so knock that out then. Go ahead and see what you get. Say you all nodded your head yes. This isn't a punishment. No, that's not what we're getting at. Okay? We want you to work on this because you're going to be responsible for this information at some point. So why not make sure that we're all on the same page? We just nodded our head yes. That we are. Okay. Somebody nervous? Maybe someone's moving their desk or not their pacing, thumping their foot. Okay. Does anyone say, I'm done? Yep, that's right. And unless you have a very good understanding of the periodic table, you're probably going to need to have your slide rule out. You're close. What problem do we have with that? When you got all the way down to here, 1, 2, 3, 4. How did you get 5? Okay. You're just too excited for what is it? Saturday night? Dallas at New Orleans? Oh, Dallas at Los Angeles. Okay. So, oh, that's right. It's Philadelphia at New Orleans. Yes, yes, yes. Well, you got it started. Is that all you're going to do, or? Okay. Well, you got it started. All right. You're doing the configuration too. Smart. At least that's what I thought you were doing, but maybe that's incorrect. Is anyone ready to throw their hands up and say, I don't get it? Okay? So, what we want to do, okay, follow your slide rule. Some of you have already knocked this out. How many of you, like for instance, some of them looked and said, yep, that's right, yep, that's right. Okay, so when you follow your slide rule, we know that we got what? 1S, okay? 2S2, 2P6, okay? Is anybody lost up to this point? Because, and just keep that in mind. If you're just writing this down, saying, I got it, I got it, I got it. But if you don't understand, you've got to say something. And then, please, come in and ask questions. Okay? So, what comes after 2P6? 3S2, 3P. Okay, and reason we're rambling these off is this is following your slide rule that was given to you earlier. So we know that there's 3D10 down here, but what comes before that? So when you see the large number 4, that's telling you we're starting our 4th energy level, 4s2, then 3D what? Okay? What comes after 3D10? 4p6. Now, we know we're not quite close enough yet for 2 reasons. One, you correctly said it was in the 5th period. Where are we at right now in this shell game? We're in the 4th energy level. We know we need to get up to the 5th because tellurium is in the 5th period. Okay? Plus, we could add all these together and we would get, what is that? 18, 20, 30, 36, 44 so far. No, that's not right. 10, 18, 28. Okay. Yep. So now, what comes after 4p6? 5s2. Okay. Now what? 4d10. Now, some of them predictions that you had correctly made no more than 5 minutes ago was said, we know it's in the 5th period. Okay? 1, 2, 3, 4, 5. Now we're in our 5th period. Okay? What column in the 5th period is tellurium in? In the entire 5th period, though. So we know we have to have 6 in this energy level so far. So what comes after 4d10? 5p6, but now what column in the p block is tellurium in? 4. So we're going to go 5p4. Okay? Remember, you had told me correctly that tellurium is in the 6th column of the 5th period, which it is. So how do we get 6 from that? 2 plus 4 gives you 6. That's why it's in the 6th column. Okay? Left outside. Left middle. Middle. Right middle. Right middle. Right middle. Right outside. Okay? So we still see some that are just not quite getting this yet. So what does that tell you you need to do? And it's your choice to do that. Okay? Mr. Hammer can't say you need to do, well, you can, but it's whether you choose to listen or not. Okay? So, if we were to do a linear representation of this, what do we call that? An electron configuration. Okay? So look at all these numbers we would have to write out of there. Is there a shortcut that we can take? Yes. We can start with a noble gas. What did the narrator say yesterday? What's true about all noble gases? They have 8 valence electrons. So do they react? No, they do not react because they're already stable. That's why they're in the 8th column. Okay, so if that is the case, we need to pick the next smallest number below 52, which we can't use xenon because that's 54. We want to go down to 36, which, okay, it looks like it's 35, but it's 36. If we're still, I'm not saying still making that mistake, please make sure you see that as 36, not 35. Okay, so if we start with a krypton core, we're already up to 36. Okay, what period is krypton in? The 4th. So what's going to come after 4p? Because you said 4th. That's right. Numerically speaking, what comes after 4? 5. And what block would that be according to your slide rule? 5s2. What comes after 5s2? 4d10. And then what comes after 4d10? 5p4. Okay, now, what happens when you add these three numbers to 36? We get 52. Okay? So when we're looking at our outer energy level, which is these, okay? There's 5s2, there's 5p4. That's where those numbers are coming from. Now, you might be thinking, well, why is this in the middle? This is what the slide rule is telling you to do. Okay? Now, we're not going to get to it today, but if you feel you are not understanding this, tomorrow we're probably going to be looking at something from probably 59 to even 71. Where is that at on your table? Which block? It's in the F block. Okay? So, again, only you can determine whether you're going to ask for extra help. Before school, SRP, your study hall, after school, although it won't work today or tomorrow because we're driving bus. But if you're the one that says, I don't get this, and you don't ask for extra help, that's probably not going to be very beneficial for you. So if you, just like learned in coaching football at a different school, again, we've done this before, where I'm not singling anybody out, and he would do the same thing. He said, if you think I'm talking about you, we probably are. So notice I'm not looking at any certain individual. Only you can determine that. Okay? So what about if we had to do another example? How many would say, I'd be lost? If you think you're that person, you're probably going to want to ask for extra help. Yes?
So if you use the noble gases, does this work for any element?
Mm-hmm.
Do that?
But I'm not going to say do the noble gas configuration for xenon. Who started snickering and laughing and thinking that was funny? Why is that funny? Because all you have to do is write xenon. We can't make it that simple, can we? Well, we could, but we're not going to. Because I'm sure in the back of your mind, you're thinking this is fun, right, people? Of course, it's probably, anything's going to be probably more enjoyable if you understand it, whether it's physics, chemistry, algebra, geometry, chemistry, any one of them. It's probably more enjoyable if you understand it, okay? But this is going to be hopefully what we consider a life lesson for you, okay? You just don't learn science in school. You just don't learn math in school. You learn life lessons, okay? All right, so continue with hunting the elements. All right.